Okay, so this video is to go over 3.5 and 3.6 scatter plots and line of best fit and analyzing lines of best fit. So some important vocabulary. Negative association means that as one thing goes up, the other thing goes down. So the more you are tired, the less energy you have to play. The faster your car goes, the less time it takes to reach your destination. The longer a candle burns, the shorter it gets. Negative correlation is when the data with a negative association are modeled with a line. No association just means that they don't affect each other at all. It's just random. So the color of your backpack and your math grade has nothing to do with one another. The height of the student and their test scores. Shoe size and the number of movies watched. So no correlation is the same thing. It's just the data with the no association modeled with a line. Positive association is when one thing goes up, the other thing goes up too. So both things are moving in the same direction. So the taller you are, the bigger your feet usually are. The more you practice, the better you get. The more you buy, the more you spend. So positive correlation is the same thing when the data with positive association is modeled with a line. Trend line or line of best fit is just a line that models the data in a scatter plot by showing the general direction of the data. It fits as closely as possible. So you want to try to have about the same amount of data points on each side of that line of best fit. Correlation coefficient measures the strength and direction of a linear relationship between two variables. Ranges from -1 to +1. Closer to -1, the stronger the negative correlation. Closer to 1 is the stronger the positive correlation, and 0 indicates no correlation. Residual is the difference between a y value of a data point and the corresponding y value from the line of best fit, or predicted y value. Residual equals actual minus predicted. So the first thing we're going to do is just identify the type of association, positive, negative, or none, and then estimate the correlation coefficient. So this first one, it's going to be a negative because as x gets bigger, y gets smaller. So this is negative. It's not a super tight association, so I'm just going to put -7.5. Whereas this is going to be a positive, and as you can see, it is super tight, almost a straight line. So I would say probably 0.9. And then this would be no correlation whatsoever. You can't even tell me close to what direction it is. So it's just going to be a 0. This one says describe the correlation of each scatter plot. And then draw a trend line that models each data set, and then find the equation of that trend line. So the first thing I'm going to do is just kind of draw my trend line. And that's going to be a positive. And we're going to scooch in, here we go, a little bit. So this looks like a point, and that looks like a point. So we're going to find our slope. So rise over run, I go up 1, 2, 3. I go over 1, 2, 3, 4. So my slope is 3/4. And then I'm going to use this point, which is 3, 3, 3. And I'm just going to plug that into y equals 3/4. I don't know why it's, let me scooch back a little bit, okay. X plus b. I'm going to plug 3, 3 in for x and y. Oops, that should not be 3, that should be 4. Times 3 plus b. So 3 equals 9/4 plus b. I'm going to subtract 9/4. Now you can use your your calculator, I'm sorry. I'm just going to go ahead and say, okay, 3/4 is the same, 3 wholes is the same as 12/4. And if I subtract 9/4, that's going to give me 3/4. So 3/4 equals b. So my line of trend, my trend line or my line of best fit is going to be y equals 3/4 x plus 3/4. Alright, now let's look at, I'm going to use red for this one. This is going to be a negative, because as your x's get higher, your y's get lower. And then if I'm just going to this, and here's a point, and there's a point. So up 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5, 6. So my slope is -5, 6. I'll use this point, which is 1, 2, 3, 4, 5, 6. Let's see here, right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12, 1, 2, 3, 4, 5, 6. Oh, I'm going here. So it looks like it's 12, 6. So I'm going to have y equals -5, 6 x plus b, and I plug 6 in for y and 12 in for x. So -5 times 12 is -60, divided by 6 is -10, so 6 equals -10 plus b. So when I add that to both sides, I'm going to have 16 equals b. So my line of best fit is y equals -5, 6x plus 16. Alright, so this says, use the equation from the line of best fit, y equals 3.4x plus 64, find the predicted values and the residuals by completing the table. So our studied test scores, predicted value and residual. So the predicted value, all you do is you plug in the x in for x. So I'd have 3.4 times 3 plus 64. Well, 3.4 times 3 is 10.2 plus 64 is 74.2. Then I'm going to have 3.4 times 5 plus 64. 3.4 times 5 is 17 plus 64 is 81. And then I'm going to have 3.4 times 9 plus 64. So that would be total 94.6. Then you have your actual minus your predicted. So I'd have 75 minus 74.2, which is going to give me, let's write it in red, 75 minus 74.2 is 0.8. Then I have 80 minus 81, which is -1. Then I have 95 minus 94.6, which is 0.4. So this is 3.5 and 3.6. Hope it helps.